Okay, so here is SuperMath80, and we've got some friends over and we're filming it in a slightly different place. And I thought I would just go over this fun problem I saw on Twitter yesterday with you that I 3D printed some pieces for. But I'd like to hear your ideas about it because it's a pretty clever problem. So it says you have two squares. This one has area R, this square.
Yeah.
Okay? This square has area S. And then you have this little triangle on top that is a right triangle that goes up to the top of this square. See that?
Yep.
And the question is calculate the area above this line. So you start at one corner and you go up to this corner. Calculate the area that's above that line. So what would you do to do that? And just be careful of your shadow because the lights are in a different place in this room.
Well,
just tell me what you would do and I'll write for you.
So I would calculate the area of this triangle. Like this triangle, that's the other. It's like this triangle, but it's reflected up there.
Okay. So what do you have to do before you calculate the area of that triangle?
So you have to find the base and the height of the triangle.
All right. What's the base?
So the base is, well, it looks like it's the square root of r plus the square root of s.
Okay. So you're pretending there's a second triangle up there?
Yeah.
Luckily for you, for a different reason, I printed a second version of that triangle. So, alright, so you're right. This is the square root of r plus the square root of s. Okay, what's the height?
The height is, it's s plus that little triangle.
Okay. So what is the height here? Then you're right.
So
how do we figure out what
the
that
square root of s plus the triangle.
Right, it's the square root of s plus the height of that triangle. So how are we going to figure out what that is?
Well, I know the base of that triangle is square root of s.
The base?
This part is the square root of s.
Ah, okay, so if we're going to look at this triangle, right, just all by itself, this is the square root of s.
Whoops.
Right, but we just have to figure out how tall this triangle is. So putting it in here should help you figure that out.
Well, it's the square root of r minus the square root of s.
Very good. So how tall is this whole piece here for the original?
That's the square root of r.
That's the square root of r because it goes all the way up. Okay, so the area of this triangle is what?
It's
the big triangle.
So it's the square root of r plus the square root of s times the square root of r, the whole thing over 2.
Okay. So I get, for my big triangle on top, square root of 1/2 base, square root of r plus the square root of s, and square root of r. Okay? Now, remember that this triangle wasn't part of my original. So we're just trying to find that area. So what do you need to do now?
Now I have to do minus 1/2. So the square root of r minus the square root of s. That's the height, and then the base is square root of s.
Okay. Well, that's interesting. So tell you what, let me slide the shape out of the way and let's do the calculation. Okay. All right. So I'm going to factor out the 1/2. From the first one, what did I get when I multiply this out? Square root of r plus square root of s times the square root of r.
You get r plus square root of s times r.
Okay, and then I have minus 1/2. What do I get when I multiply this out?
Wait, didn't you factor the 1/2 out?
Oh, sorry. I said that. You're right. I was wanting to ignore the 1/2 for a second, but now I changed my mind. I'll pay attention to them. Sorry for being confusing.
So, this is the square root of SR minus minus S.
Okay. So I have 1/2, and I just have to be careful with my 1/2s here. 1/2 r plus the square root of SR minus 1/2 times the square root of SR minus S. So what does this simplify to become?
Well, you can multiply the minus through.
Okay.
And you get...
Let me just write this. R square root of SR
plus... Well, if we multiply the whole minus, well, it's minus SR.
I guess I gotta remember my half. Minus SR square root.
Yeah. Mine plus S.
Plus S.
Yeah.
So the whole thing simplifies to be?
Well, wait. Well, when you add these two together,
Yep.
so you get the plus SR and the minus SR cancel out.
Well, remember it's a half SR and a half minus SR.
But it's the plus SR over 2 and the minus SR over 2.
Yep.
So you're left with R plus S over 2.
That's pretty cool, right?
Yeah.
R plus S over 2. Now let's bring the picture back.
Yeah, that.
There we go, sorry.
And then,
So the interesting thing, what is the geometric interpretation of R plus S over 2?
so it's the area of this plus the area of this. Not,
What
not,
are
it's the
this
area of
and
the
this?
big square plus the area of the small square, all over 2.
Yeah, so the interesting thing is the area above this line is exactly equal to half the area of this square plus half the area of that square. That's really neat, isn't it?
Yeah.
Yeah, I thought that was kind of a fun problem, so I did a little project on my own about that problem yesterday. But good job. High five.